Exercise 6C, Complementary Relationships. Today we are learning about the complementary relationship between sine and cos, and what you need to be able to do is describe the relationship between sine and cos, and then find the complementary angle based on the quadrant. So what are complementary angles? Well, unlike this photo, it's not about complementing each other. To give someone a compliment, that's an I. Instead, complement with an E means it completes. So it's actually quite sweet anyway, they complete each other. You might have looked at it from year 7 to 10, but basically the angles need to add to 90 degrees. So if I have an angle 30, I need to add something so that it completes it to equal 90 degrees. So in this case, it would be 60. So that's what a complementary angle is. Now, this is a very complicated diagram of what we're going to do today, but it's actually not this tricky. I'm going to try and describe it in a very easy way. If I have my Cartesian plane here, if I have a particular angle, say I have 30 degrees over here, so that's pi on 6, the unit for this, or the coordinates rather, cos of pi on 6 is root 3 on 2, and sine of pi on 6 is 1/2. And I might just write 30 degrees because it might make a little bit more sense using that degree angle. Now, if I have a similar angle, but not the same, this time I'm going to do pi on 3 as my angle, and that's going to be 60 degrees. If we try to explore, well, what's the coordinate of that going to be? Well, sine of pi on 3, cos of pi on 3 is 1/2, and sine of pi on 3 is root 3 on 2. So what do we notice? There's something very interesting here. Well, basically, it's just the opposite. That's all that's happened. So can we try and draw a relationship from this? So, for example, we know that sine of 30, which is 1/2, is the same as cos of 60, which in this case was 1/2 as well. How can we write this in a nicer way? Well, what if I leave sine of 30 and let's write 60 as having something to do with 30 so that we can have a common value? Can I rewrite that as cos 90 minus 30? Now that's really nice because firstly, I can see that I've got something common here. And secondly, I'm using 90 degrees, which are the key axes. So the key axes we usually use are pi and 2 pi, but pi and 2 are also very important axes. That's our 90 degrees. So in general, what we can say is that sine of any angle is equal to cos of 90, or if we use radians, pi on 2, minus that exact same angle. And that there is our complementary relationship, that if we just take that angle away from 90 degrees, we actually end up with the same. So it's the same idea here. If we were to use cos of pi on 6, which is root 3 on 2, that's equal to sine of pi on 2 minus pi on 6, which would be root 3 on 2. So that's our first complementary angle. So if we go back now, hopefully all of these would make sense. So we've got sine pi on 2 minus theta is equal to cos theta. You can see that we have that common thing there, and then the exact same thing applies over here. As you can see, what we're doing is we are working within this quadrant. So it's pi on 2 minus an angle, pi on 2 minus the angle, but the exact same thing applies if we add the angle as well. So sine of pi on 2 plus theta is the same idea, it's cos, but there's something interesting here. Cos pi on 2 plus theta is equal to negative sine theta. Why is that the case? Well, it's simply because sine in this quadrant, in quadrant 2, is positive, the y value is positive. However, the x value is negative. That's why we put a negative in the front. So our sines, our cast, or whichever one you want to use, still applies in this situation. So that's saying this here. This is just an indication of what the actual formulas are going to be. So that's pi on 2, that's 3 pi on 2. And now you know pi on 2 minus theta plus theta ends up there. And then 3 pi on 2 minus alpha is there, 3 pi on 2 plus alpha is here, and the signs stay the same, so it's whatever the original one that you're using. So if I want sine of pi on 2 minus theta, that means I'm looking for the y value, and the y value, for example, is negative here, so we would include a negative. So let's go ahead and apply all of these concepts to this example. So example 7, if sine theta is equal to 0.3 and cos of, actually don't know what that is, if anyone knows, please let me know, is equal to 0.8, find the values of. So we have sine pi on 2 minus this, I'm going to call it trident. I know it's not a trident, but let's go with that. So I know part of my complementary relationships, first of all, that this is in this quadrant. So sine is positive, that's all good. And the complementary relationship tells me that that's going to be equal to cos of trident. So cos of trident, we already know what that is. That's 0.8. So it's as simple as that. Part B, same idea. This time it's pi on 2 plus theta. So we're in this quadrant, and in this quadrant, cos is actually negative. So we just have to keep that in mind, that that's going to be negative. Part of the complementary relationship means that that's equal to sine theta. So it's sine of this particular angle. In this case, that'll equal to negative 0.3. And then the last one is sine of negative theta. It's not really complementary. We've spoken about negative angles before, but if you remember, that is in this quadrant here. We don't have to worry about going backwards. All we need to do is use our negative angle formula, so negative sine theta. So remember, it's the same as sine theta, but the opposite sign, which is why we have that negative. So it's positive there, negative there. That's the explanation as to why. You can just go straight to the formula. Sine theta is 0.3, but we want the negative of that, so that'll be negative 0.3. Again, for the next example, find all the values of theta between 0 and 360 for which cos theta is equal to root 3 on 2. I'm actually thinking that this belongs to an exercise that is a little bit later on. So you don't have to worry about this here. It actually doesn't belong in this exercise. So you can just go ahead and cross that example out. You don't need to worry too much about it. But we will do this example here. So for pi, for x between pi and 3 pi on 2, with cos x is equal to negative sine pi on 6, find the value of x, but do not evaluate what is sine pi on 6. So this does look a little bit confusing at first, but what we're basically trying to do is trying to work out with this complementary relationship. Now, cos of an angle is equal to negative sine pi on 6, and we want to just work out what is going to be that x. So we don't want to work out what this is, because that would defeat the purpose. Now, the first thing we can start off with is this. This tells us that we're in the third quadrant. So we're over here. The other thing that indicates that is the fact that cos is equal to negative. So that means we are also somewhere where cos is going to be negative. That can only be in the second or third, and this, of course, confirms the fact that we are in the third quadrant. Now, the other thing is we want to think of that complementary relationship. So if we have sine of 30, we know that cos of a particular angle, I'll just write this in general, well, that 3 pi on 2, and then in this one, it's 3 pi on 2 minus the angle. So from there, we can find out, well, what is x? Because negative sine 3 pi on 2 minus a specific angle needs to equal to sine of pi on 6. Now, since the outsides are the same, we can just grab this. Pi on 2 minus x is equal to pi on 6. I'm going to take the x to this side. I'm going to take the pi on 6 to this side. 3 pi on 2 minus pi on 6 is equal to x. I can multiply both the top and the bottom by 3 to make the denominators the same. So that's 9 pi minus pi, all on 6. 9 pi minus pi is 8 pi on 6. And then if we simplify that down, that will be 4 pi on 3.